Welcome to The Explainer. Today, we are diving into a pretty incredible story from the world of medicine. We're going to see how artificial intelligence is breathing new life into a tool that's over a century old, unlocking secrets that, it turns out, have been hiding in plain sight this whole time.
For decades, the ECG, that familiar printout of your heart's rhythm, was kind of seen as, well, a bit boring. It got completely overshadowed by all this flashy tech like MRIs and CT scans, and it was sort of pushed into a corner, treated like just a basic screening tool.
But it turns out we were totally wrong. We really thought we had squeezed every last drop of information from those squiggly lines, but the ECG was hiding a whole universe of data, and AI just handed us the key to unlock it.
Okay, so let's start with the problem itself. For years, the humble ECG was looked at like a medical veteran. Reliable, but way past its prime, with really nothing new to offer. The core belief, really, was that the ECG's value was capped by what a trained cardiologist could see with their own two eyes. We just assumed we had already learned everything those waves and intervals could possibly teach us.
And then AI entered the picture. What's so fascinating is that it didn't change the ECG test one bit. Instead, it just gave us this profoundly powerful new way to read the data that was already there all along.
And this slide really gets to the heart of it. See, classic machine learning is like teaching an apprentice our own rules. We tell it exactly what to look for, and basically it just automates what we already know. But deep learning, that's a whole different ballgame. We give it thousands of ECGs, we give it the final diagnoses, and we just say, you figure it out. And what it does is discover these incredibly complex patterns that were completely invisible to us. So this is the really critical shift. The ECG is no longer just a snapshot of what's happening right now. It's becoming more like a crystal ball for the future. Let's look at 3 absolutely game-changing examples of this in action.
All right, case number 1. Just imagine a 65-year-old patient who goes to their family doctor with some really vague symptoms. They're just getting a little winded more easily than they used to.
Okay, so a human doctor looks at the ECG, sees some minor, non-specific changes and says, you should probably see a specialist, but there's a 6-month wait. The AI, in just 3 seconds, flags a 91% probability of a seriously weak heart pump, a condition that points to a major structural problem with the heart.
Now, this isn't just about being faster. The AI used a simple electrical test to spot a mechanical problem. It's basically acting as a screening tool for an ultrasound. This one discovery completely changes the patient's care path, getting them urgent treatment and quite possibly preventing debilitating heart failure down the road.
Okay, next up, let's consider a patient who had a minor stroke, but the doctors just can't figure out why. So they do an ECG, and it looks perfectly normal.
So the human eye sees a totally normal heart rhythm, which means the cause of the stroke is still a mystery. But the AI analyzes that exact same normal ECG and predicts an 85% chance that this patient will develop atrial fibrillation, a specific, dangerous, irregular heartbeat sometime in the future.
What the AI is doing is reading the underlying electrical texture of the heart muscle. It's seeing the conditions that make that arrhythmia likely even when it's not happening right now. It literally saw the risk of a fire before there was even any smoke, which lets doctors hunt for the problem and treat it to prevent another, bigger stroke.
And for our final case, picture this. A diabetic patient comes to the emergency room feeling generally unwell and weak, a super common and really non-specific complaint. An ECG is done right away. A busy ER doctor glances at the ECG. The T waves look a little tall maybe, but not like the textbook danger signs. They decide to wait for the lab results, which will take an hour. The AI, meanwhile, instantly flashes an alert. Over a 90% probability of life-threateningly high potassium. See, the AI is just incredibly sensitive to the absolute earliest signs of this deadly imbalance. So the team can start life-saving treatment immediately, long before the lab even confirms the danger. In all 3 of these cases, the AI used the same old test to see something that was simply invisible to us.
So this all leads to the big question, right? How in the world is the AI doing this? What is it seeing that we can't?
Well, the answer lies in a really fundamental difference between how our human brains are wired to perceive information and how a machine can analyze it.
We humans are pattern recognizers. Our brains look at, say, 10 heartbeats on a page, and we average them into one representative shape, and we just dismiss all the tiny little differences as noise. The AI does the exact opposite. It analyzes the statistical relationship of every single data point, finding profound meaning in these tiny variations between beats that are completely imperceptible to us.
And this is the key concept, the secret sauce, beat-to-beat morphological variability. That noise that we've been ignoring for 100 years, it's actually a powerful signal. It can be the chaotic electrical signature of a diseased, scarred heart muscle. And for the very first time, we have a tool that can actually read it.
But of course, this raises a huge question. If doctors can't see what the AI sees, how can they possibly trust it? This is famously known as the black box problem.
The solution is this amazing field called Explainable AI, or XAI. So when an AI makes a call that seems weird to a doctor, the doctor can essentially ask it, "Show me your work." The AI then provides a heat map, highlighting the exact parts of the ECG it was focusing on. So even if the doctor doesn't understand the deep reason why those spots matter, they can see where the AI looked. The black box becomes a much more trustworthy gray box.
And this all brings us to a truly remarkable conclusion about this century-old piece of technology.
By simply applying a more powerful way of reading data, AI has unlocked information that was always there, just hiding in the noise. It has completely transformed the ECG from a simple diagnostic tool into a powerful weapon for predicting and preventing disease.
The story of the ECG's rebirth is almost certainly just the beginning, and it leaves us with this really fascinating question. What other secrets are hiding in plain sight within the oldest and most common medical data that we collect every single day?